Okay, so now we're going to tie together the friction factor to this head loss quantity. That's what we're going to do right now, right? So first, if you talk about a friction factor, it's good to write, you can always write this definition out of what a friction factor is. Remember, this is true for laminar or turbulent flows. It was true for laminar turbulent flows because this quantity actually takes in the effects of laminar turbulent flows. But this expression is always the same. Okay, part 2, we said that our major head losses were equal to a change in pressure over the rho g. By the way, I did have an extra credit. I did have an extra credit. Just tell me why did we go to this point of dividing by a rho g to put it in units of distance? So maybe just like a long little post about why engineers decided to use this concept of head loss instead of just energy. Because I like energy, but there was a reason behind it. So that's it. Now all we do is we solve for this using this equation, and then you'll get that head loss. And this is the biggest equation of this whole class, I'd say, is knowing this one. So before in lecture 3, what we did was we practiced on getting this term here. Just getting that friction factor, because there's a lot of counting that works to just get it. And then you'll see how you use it, because now you have to do bookkeeping on the pipes that you have, and then you have to kind of figure out what these velocities are along your pipe system. But this one's non-intuitive of how you get these dimensionless Darcy friction factors. So that's why it has its whole other class. Now we can get to using it, and you'll see how these major largesses come about. So one other thing is, what velocity do I put in here right now? It can be confusing if you don't remember the story of all these derivations we did, but always tell yourself, use the largest velocity possible. So this is the maximum velocity that you could find in the pipe. And that's because the friction factor, when you derive it, you account for using the maximum velocity. So don't forget that. Really, it's just a characteristic velocity. So if you actually measured things in pipe, you could just measure a velocity and put it in this idea to figure out what these head losses are. But just always remind yourself that you're using the biggest velocity value possible, because you're going to get then conservative estimates on this, right, head loss or energy required to overcome viscous forces.